So let's start with the basics. What exactly is RAM? RAM, or random access memory, is a type of volatile memory. That means, it only holds data temporarily while the computer is powered on. Unlike storage devices such as hard drives or solid-state drives, RAM doesn't retain information after shutdown. It's called random access, because the CPU can, access any memory cell directly instead of going in order like with traditional storage, say, a hard disk, where files are read sequentially. This makes RAM incredibly fast compared to storage devices. So, how does RAM actually work? Let's break it down a bit. When a user opens an application, the CPU fetches the necessary data from storage, like an SSD or HDD, into RAM. The RAM then temporarily holds this data, making sure the processor can get to it quickly and, well, avoid those slow disk reads. As long as the application is running, its relevant data stays in RAM, cutting down on the need for repeated disk access. So, RAM operates using a memory address system, which means each data block has a unique address for rapid access. While RAM is fast, CPU cache memory like L1, L2, and L3 is even faster. Cache temporarily stores frequently accessed data, and that helps reduce RAM access times even further. Still, RAM plays a crucial role, acting as a buffer between slow storage and those really fast CPU operations. So, let's talk about multitasking capability. More RAM, allows multiple applications to run smoothly without slowdown. When it comes to gaming and graphics processing, games actually load high-resolution textures into RAM for fast rendering. And for software and virtual machines, applications like video editing software and virtual environments really do demand high RAM capacity. Efficient data processing is another big one. RAM speeds up computational tasks by reducing reliance on storage drives. Without sufficient RAM, a system resorts to virtual memory, which is basically a slower backup system using disk storage, and that unfortunately leads to lag and performance drops. RAM's performance is impacted by several key technical factors. One of the most important is capacity, measured in gigabytes. 4 gigabytes is good for basic tasks like web browsing or office work. 8 gigabytes covers standard use, such as multitasking or light gaming. 16 gigabytes is ideal for heavy tasks like gaming, video editing, or programming, and for high-end applications, think professional software, three-dimensional rendering, or AI processing, you'll want 32 gigabytes or more. So let's talk about speed, measured in megahertz or megatransfers per second. RAM modules come in different speeds like DDR4, which usually ranges from about 2,400 to 3,200 megahertz, or DDR5, which starts at around 4,800 megahertz and goes up from there. The higher the speed, the faster data can move between your RAM and your CPU. Next up is latency, often referred to as CAS latency, or CL. Basically, lower CAS latency means your memory responds more quickly when your system asks for data. For example, if you compare CL16 RAM to CL18 RAM, the CL16 will respond faster, which can help reduce system lag. Now let's look at type and generation. DDR4 and DDR5 are the most common types these days, and DDR5 is the latest, offering higher speeds, better efficiency, and increased bandwidth. And then there's the physical form. SODIMM is what you'll find in laptops, while DIMM is typically used in desktops. Alright, let's talk about dual-channel versus single-channel memory. Dual-channel memory, actually increases bandwidth and improves performance, especially when it comes to gaming and professional tasks. By using two identical RAM modules like two 8-gigabyte sticks instead of just one 16-gigabyte stick, you enable dual-channel mode. Before buying RAM, keep these points in mind. Compatibility. Check motherboard specs. Some boards support only DDR4 while newer ones support DDR5. And make sure to verify the maximum RAM capacity supported by your system. Capacity versus future upgrades. If multitasking is important, it's a good idea to opt for more RAM now, or, at least ensure upgradability. Speed and latency balance. High-speed RAM really benefits gaming, but latency also plays a crucial role. Cooling and overclocking. High-performance RAM often comes with heat spreaders for cooling. Also, some RAM modules support XMP profiles for overclocking to boost performance. While RAM is the backbone of computer performance, allowing fast access to active data, improving multitasking, and preventing lag. Whether you're choosing RAM for a gaming PC, professional work, or just general use, understanding these factors helps you make a smart purchasing decision. So, next time you upgrade your PC, remember, the right RAM can really transform your computing experience. If you found this video helpful, don't forget to like, share, comment your thoughts or questions below, and subscribe for more tech tips.